Discuss the first law applied to heat exchangers and turbines. Now, a heat exchanger is a device where one flow will be interacting with other flow for exchange of heat. So, for example, you want to have several tubes like this. Now, these tubes here, for example, steam is passing here, and the steam will be condensed in this container MS and MS in one. So MS in and MS out. Now here cooling water MC, cooling water will be inletted and MC will be outletted. Now this is section 1.1. This is section 2.2. This is section 3.3. And this is section 4.4. Now for this heat exchanger, that means the cooling water will be flowing in these pipelines and steam will be passing through these cooling waters, and this steam will be cooled and collected in a container. This is what is called a heat exchanger. Now in this heat exchanger, we are applying the first law of thermodynamics for flow process. So here MC into enthalpy at inlet 1 plus MS MS1 and enthalpy at 2. This will be equal to MC2, this 2, and 3, MC3, H3 enthalpy at 3 plus MS4 plus enthalpy 4. Now, the equation here is the velocity head at inlet is same as velocity at the outlet for the steam for cooler, and velocity at inlet for steam is same as velocity at outlet. Now, enthalpy will be only considering in this inlet and outlet, and this is the balanced first law for heat exchanger. This is the heat exchanger. Now consider the same thing, the first law applied to turbine. And in the heat exchanger, you don't have any heat, only the system and surroundings, there is no work transfer, there is no heat transfer. Whereas in case of turbine, there is no heat outlet, okay, and there is only work that is coming inside, and there is a heat mass inlet and mass outlet. So here P1 V1 plus U1 plus V1 square by 2G plus delta Q plus Z1 you can neglect. This is equal to U2 plus P2 V2 plus V2 square by 2G plus W plus H2 plus Z2. Now we can neglect the velocity head because the flow is something like that. the heat transfer is not there. The height you can consider neglected. So the work done is equal to H2 minus H1 into M, mass flow. This is the equation for turbine and applied to when you are applying first law of thermodynamics. So these are two examples I would like to discuss in a small video session. One is if you neglect all the velocity head and heat transfer and work transfer, the mass at fluid inlet at 1, mass flow at steam at 1, at 2. This must be equal to mass flow as steam at 3 plus mass flow and steam at 4. So these are the two applications that I would like to discuss for the application of first law of thermodynamics, heat exchanger and turbine. Thank you very much.